Good afternoon and welcome to today's Machine Design and Power and Motion webinar entitled Mastering Thermal Management in EVs, Insights into Hose and Fitting Solutions for Enhanced Performance and Sustainability, sponsored by Parker Hannifin. I am Sarah Jensen, Executive Editor of Power and Motion with Endeavor Business Media, and I'll be your moderator today. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during the session, please submit to the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Machine Design and Power and Motion websites within the next 24 hours. You'll be notified by email when the archive is available. Now, I would like to introduce you to our speakers for today's discussion. First up, we have Stephen Powell, who brings over 25 years of expertise in the engineering, design, and production of thermoplastic hose and tubing products tailored for fluid power and conveyance applications. Throughout his distinguished career, he has been granted numerous patents, significantly contributing to Parker's intellectual property portfolio. Also joining us is Jeff Berger, who has a 35-year track record in product design, applications, and product management, specializing in rubber hose and fittings for thermal cooling applications. His tenure at Parker is marked by a series of patents. Throughout his career, Jeff has actively contributed to various industry organizations, playing a pivotal role in elevating industry standards to new heights of excellence. We also have joining us today Nathan Green, an applications engineer for Parker's Tube Fittings division. He brings 15 years of extensive experience in the engineering, design, and application of fluid conveyance connection methods across numerous markets. Nathan holds numerous patents for novel technical solutions that have been developed with customers. So thank you all for joining us today. And Stephen, if you'd like to go ahead and start the presentation.
Sure. Thank you, Sarah, for the wonderful introduction. I'm happy to represent Parker today and also to share with the people that are attending our insights and the experiences that we have gained over the last few years working on battery electric vehicles and the transformation towards zero emissions and decarbonization. Our agenda is pretty straightforward. We're going to cover some regulatory guidelines, kind of talk about why are we here and what's driving the market changes. Then we'll discuss some of the standards that cover the hoses and fittings that you're going to be using in your cooling applications. Then we'll share insights on design considerations, some of the experiences we have seen between prototype builds and also serial production. And then we'll finish up our presentation with a Q&A session. The presentation should take about 35 minutes, and like I said, we'll follow it up with Q&A. So why are we here? I was at the ACT show in last month, and it was really well conveyed by all the guest speakers that there is a global effort towards decarbonization. I utilized Microsoft Copilot AI tool just a couple nights ago to see if it could tell me how many companies and how many countries have signed up or made commitments to decarbonization. And it's pretty amazing. There's over 130 countries that have made a pledge to decarbonization, and also 163 Fortune 500 companies. So the effort is definitely there. While the path to decarbonization there's going to be a lot of starts and stops based on what I heard at the ACT show, but there's definitely a lot of momentum towards achieving that. So, in the U.S., one of the key drivers is the California Air Resources Board. They are definitely leading the effort in the country in terms of regulatory requirements. And three items when you dig into the details is, one is the manufacturing mandate. Starting in 2040, the state of California will only allow zero emission vehicles to be registered within the state. So that is a big target out there for people manufacturing vehicles for moving people and goods. Also, state and local agencies, anybody that's using state funding has to start that conversion immediately beginning 2024 and with a target of 100% of the state and local funded vehicles being battery electric by 2027. That is a really short timeline. There's a lot of concern about having the appropriate infrastructure in place to support that. So my guess is that there'll probably be some relaxation of those standards, but it appears that they're still moving forward with those requirements. One area that piqued a lot of interest to me is the improvement that they're trying to achieve at the ports and the air quality. Some of the commentary I read was that some of the areas near the ports are some of the most impoverished areas in the state, and they were trying to really clean up the air quality there because currently it's some of the worst air quality in the state. So there's very specific legislation to focus on those areas, and that transition is starting this fiscal year or this calendar year. So a lot of effort in California, and it's driving a lot of activities within the OEM community. Also within the U.S., there's multiple states that have signed on and have agreed to follow the California legislative efforts. So it's starting to take root throughout the rest of the country. We have a big election coming up this November, so there's no idea what the outcome is going to be for that. But seeing that there's so many countries and companies that have signed on to decarbonization, I do not think that this trend is going to stop moving forward.
So some of the standards that we see utilized in this industry, from the hose, the fittings, and the threaded connections, we see following SAE J20R, which is an automotive coolant hose specification. And it's also designed for a heater hose. And so that's some of the hose specs. And in regards to the connections of the hose ends, we see following J1231, which traditionally is like the beaded end or the hose barbs. And then one of the new specs is the J3207, which is for the VDA fitting, which the guys are going to get into here in a little bit. Another connection that we see from the automotive industry is the J2044. It's a quick disconnect that was designed for fuel line and coolant many years ago, and we're seeing that quite a bit. And in regards to the specifications for the threaded connections, what we see is SAE J1926 and then also ISO 1179. So where is thermal management critical, especially on an EV? So there's three areas that we see. One being the cab, where a lot of electronics need to be cooled. The second is the energy source, which in this case would be a battery. And the guys are going to get into how critical it is for thermal management on those components. And then the third area that we see actually is the actual, the components, the equipment, the electric motors, the pumps, inverters, chillers. All these requirements basically for efficiency are required to be cool. So that way they maintain 100% or higher, actually not higher, but efficiencies towards 100%. So that way the operation is as efficient as possible. With that.
So going into the e-mobility, e-work cooling requirements, what is different from internal combustion engine systems and battery electric or battery powered systems? There's generally two new systems that you're going to encounter on new vehicles or new equipment. One is what is discussed or called the battery thermal management system. Typically, it's a dedicated system just for managing the coolant requirements for the batteries. In addition to that, there's a secondary loop that will be used generally for the inverters and motors and the systems that are doing the work or propulsion. Here's a good schematic of it. So what we're going to do is we're going to go into the different components that are new on a battery electric vehicle or e-work system and talk about the hose sizes that are typically required, the type of connections that we see, and talk about the temperature ranges and working pressures of those components. First up is probably the newest component to everybody here is the battery pack. The battery pack, I call it the Goldilocks of the system. It doesn't like the temperature too hot or too cold. It's very temperamental and it needs to operate within a very specific temperature. Otherwise, you could damage the batteries, which are very expensive, as I'm sure everybody understands. The typical temperature requirement for batteries is between 5 and 25 degrees C. So even in very cold weather, when you turn your unit off, there's going to be warm water circulating through the batteries to keep them at the operating temperature so that you don't lose charge and lose performance when you want the vehicle or unit to work. The typical hose size that we see feeding battery packs is generally 1/2 inch or 5/8. I think 1/2 inch seems to be the most dominant that we've seen in terms of the size of hose needed. Typical working pressures are 2 bar or less. Now, when it comes to the fitting styles that are available on the battery packs are the widest range that we encounter on any of the components in the system. These fitting styles are generally offered and pre-installed by the battery pack manufacturer, and they generally do not want you to change those out, which could impact your warranty. Fittings that we have encountered include general hose beads, J24 fittings, and also a VDA fitting. A VDA is a new fitting in the US. It was developed in Europe and adopted by many manufacturers in China, and we're seeing that populate and becoming more available and installed on equipment in the US. The next component that's new is the inverter or the motor controller. It has a much wider operating temperature, more similar to general internal combustion engine, rated to -40 degrees C, so it doesn't need external heating and cold temperatures, but the max temperatures are typically 60 degrees C. Similar to the battery pack, the hose sizes that we encounter is typically 1/2 inch or 5/8. Similar working pressure. One difference here is that generally inverters are offered with threaded ports. The supplier may or may not offer it with hose connections on it. Typically, the threaded ports are offered in either a BSPP or a straight O-ring thread, metric style or imperial. The next new component and last that we're going to discuss for the new components is the electric motors or propulsion or work motors. Same operating temperatures as the inverters, -40 to 60 degrees C. Typically, the hose sizes may be a little bit larger here, but from what we've seen is 1/2 inch to 5/8. Obviously, if you have a really large vehicle or doing significant work function, that motor is going to be quite a bit bigger and you'll need more coolant for it. Same pressure ratings and also threaded ports. Now we're getting to a couple of the legacy components that have been borrowed from internal combustion engines and similar vehicles and equipment. Generally, your coolant pump is going to be is the heart of the system. It provides the pressure for the flow. We're seeing flow rates up to 95 liters per minute for some very large, heavy-duty, over-the-road vehicles. Operating temperatures coming from internal combustion engine systems, -40 to 120 degrees C. Generally, these products are offered with a hose bead. It's molded into the product, and there is no options for you to change that to something different. And then last but not least is the radiator. This is, again, borrowed from internal combustion engines, similar operating temperatures and pressures as the coolant pump, and again, basically offered with a hose bead. Typically with the pump and the coolant, the largest hoses that we've seen has been about an inch and a half ID, smallest about 5/8.
Now that Steve has covered the main components in the EV design and for these components, we'll look at some of the design considerations of the fluid conveyance system and the components for these. Through our collaboration with customers, we've developed a decision tree to help guide this discussion. Many times, these main components are already pre-selected, and the connections that are on them may be what they are, with very little change or with very little option to change. The first portion that we look at is the system requirements. What is the size and type of connections on each individual component different? This will assist us in narrowing down the hose sizes and options that are available to us. Second is the system operating conditions. What coolant is used? This ensures that we make sure we have proper system material compatibility and temperature and pressure limits that are being accounted for to maintain optimal performance. From a routing and flow standpoint, are there any valves or sensors that are desired or required in a system? Are there any areas that manifolds or T-fittings could be used to streamline the routing design? The fourth thing would be any kind of assembly or service preferences. Are there any design preferences for assembly familiarity that are typically used within your manufacturing environment? Or is there any preference from the design team? Are there any historical or MRO preferences that are used in your system? These choices can lead us to select certain hoses or fitting styles that are available. Lastly, as we look at the overall system, we like to ensure that the information is similar between individual components as well as the entire system. As some customers have different teams over different components or subsystems, we help to facilitate looking at this overall system for uniformity. Next slide. Now, let's discuss a few quick terms that we'll be using on the next slides, or if you have a design consultation meeting with us, you'll hear us use them there. The first would be a tube or hose connection, and this is basic as it sounds. Here, we're looking at how to connect the hose to the adapter or the component. This is typically a hose bead, could be a crimped hose end, or even more common in the space is the quick connect options that we will discuss later. A port. This is a threaded end. Typically, the female side is on a manifold or a component, such as the inverters and motors. These are typically NPT, although we are seeing a lot of customers very interested in moving to an elastomeric sealing option, such as BSTP or SAE. An integrated connection. This connection is molded directly into the component and cannot be changed. Typically, these are hose beads on legacy components, as Steve mentioned, such as a cooler, radiator, or a pump. Some newer designs that we've come across do have the integration of a quick connect style, whether that's the J2044 or the VDA design. And lastly, a separable threaded connection or an adapter. This just allows for a customer to change out that style for overall system uniformity. These are port ends, NPT, BSTP, SAE. First connection style we'll dive into is the hose beads. Hose beads can either be manufactured per an industrial standard, such as SE J1231, or they can have proprietary designs for different hose manufacturers specific to that hose manufacturer's hose construction. Barbs or beads allow for the hose to be pushed on ancillary clamps, sometimes without ancillary clamps. These different clamping technologies or push-on technologies allow for leak-free performance. Many customers do utilize a worm gear clamp or a spring clamp, and some have even moved towards a constant tension clamp to maintain leak-free performance. Hose beads, as mentioned, they have readily available components, whether that's adapters with hose beads on them or the clamps that are necessary. And they offer a lot of interchangeability between many different styles of hose construction and manufacturers with this SAE J1231 standard. Some of the cons of a hose bead is that it can be slower to assemble, especially as you move towards serial production. The hose bead fitting design will restrict flow, so it can be more difficult to characterize your flow of the system because you need to understand the specific diameter of these hose beads. And they can be prone to leaks if misassembled. From a quick connection standpoint, there are two main connector styles that we've seen in the market space. The SAE J2044 quick connection style is prevalent in automotive fluid conveyance, typically seen on fuel delivery systems. They have readily available components in the marketplace, and they have some familiarity between designers as if they come from that background. SAE J3207 was released in January and is typically more known as the VDA. VDA is a more compact quick connect design developed in Europe, and this design allows for a full flow through the fitting and hoses, meaning when you design in a 12 millimeter VDA connection, the flow path is 12 millimeters. That is through the fitting and the adjoining hose. Unlike if you use a half-inch J2044 connection that has a flow path of 8.4. It's not as well known, it's not as easily recognizable when designing in your system. These connectors allow for an ergonomic assembly with reduced cycle time. The VDA connections have this full flow capability for easier flow characteristic calculations. Since these are industrial standards and have gone through many years of development and qualification, these are engineered to be leak-free solutions. A few cons that they have is that there can be a limited hose compatibility. So if you are looking at these designs, you may have limited hose choices for your system. And they can add some bulkiness to the routing that needs to be accounted for. And then one unique thing about the quick connection style is that some customers have utilized both designs for a poke yoke implementation across their system. For threaded ports, there are two main styles of ports that are used: tapered designs and O-ring sealing designs. Tapered designs, most commonly being the NPT, but could be BSPT, especially if components are coming from Europe or Asia, is a very familiar design across many different industries. This means that the components will use this as the standard option for ports primarily. Many customers are asking us for assistance in moving away from NPT as they see issues with this. And they're looking for a more established connection for a leak-free design. These connections can be SAE, metric, BSPP, and they offer a more consistent assembly procedure for production level systems. Threaded ports can give customers the flexibility of the hose type or connection that they use. They allow for reusability of a component, meaning that if you have an integrated barb and the barb gets damaged, that entire component may need to be replaced. If a threaded adapter is used, just the adapter would need to be replaced. The O-ring seal is very reliable and has been around for decades and used in many harsher environments, especially in like high pressure hydraulics. Some of the cons, there's always the cons. The threaded ports can be an additional leak point. Depending on how the designer is doing their system, this is out there. And there can be installation challenges for the overall system. Thus, it is important what you are using during the design phase of the system to ensure you are mitigating these cons. They can also have a pressure drop implication in your system. So now that we've covered some of the basics, I'm going to discuss a few key items for the overall system. Many systems are utilizing or could utilize manifolds. Manifolds allow for a concentration of these connection points, typically seen coming out of a radiator or a distribution system across the entire system. Or they optimally distribute coolant to a bank of components, such as a bank of batteries. This concentration of connections can eliminate some of the threaded adapters in a system or overall hose connections in the entire system. They can allow for a designer to integrate multiple connection styles for more compact plumbing. For instance, if you're coming off a radiator with a hose bead and you need to go to a component with a VDA connection, this can be done through a manifold, allowing for distribution off of this as well. And as we think of moving to an MRO service application, we can also simplify applications that are more MRO friendly. The material choices we've seen customers utilizing are stainless and aluminum, primarily when it's a metal component, and easily customized for a specific application. When it comes to production readiness, we've seen customers increasingly interested in moving to a plastic manifold, which can even further eliminate threaded adapters. The next design consideration for the system is hoses. These hoses will connect all your main components. We've typically seen customers utilizing a rubber hose solution above 1 inch and thermoplastic solution smaller than 1 inch. Rubber hoses primarily have hose beads and clamps as the connection method and can be up to, or in thermoplastic, can be up to 50% lighter than the rubber hose if weight is of importance. When it comes to routing of hoses, bend radii are very important to conform to. Rubber hose is more flexible than thermoplastic, but thermoplastic can be thermoformed if routings are thought out ahead of time in tight spaces and routings. When it comes to valves in a coolant system, these are a much newer addition to the system. Some system designs are looking at restricting coolant circuits during and making sure that only specific components are being cooled at that time. Some designs are looking for MRO optimization and being able to isolate certain components for maintenance or removal of a component without draining the entire system, or introducing air or contaminants into the system. A few specific type of valves that we see customers looking for are air bleed valves for air removal if there is air in a system, and isolation valves to allow for a coolant vacuum fill of the system. Air bleed valves are typically placed at the highest elevation of the system to eliminate any trapped air. The last unique design consideration would be sensors. Many customers are interested in including pressure and temperature sensors in the system for continuous data integration and feedback. This has been primarily in the prototype stage, but since these sensor ports can be integrated into manifolds or fittings, these can be kept in their system for production for additional system feedback. Integrating these sensor ports can allow for optimal sensor locations, which can extend the life of your main system components. Many sensors are common with NPT threads, although more customers are interested in switching these sensors over to SAE for optimal sealing reliability. I'm going to turn it back over to Steve to discuss some of the considerations between prototype and production design stage.
Thank you, Nate. So some of the differences that we see when we initially engage with customers is there's a big difference between engineers starting on a new design, doing prototyping, system integration, really getting a good feel for how a battery-powered unit's going to work. Typically, a lot of the effort is on the system design and validation, with a lot of effort and emphasis on speed and flexibility. So typically what we see is the consideration for fluid connectors and the coolant distribution system is usually an afterthought. And engineers generally will utilize what's common in the shop, come up with a lot of homegrown solutions in terms of manifold designs, and utilize just a lot of typically rubber hose with a lot of clamps. I like to call it either the Granger or McMaster car solution thing, things that they can order and get delivered the next day. So there's a big difference, and we realize that. And at this point in the stage of your product development, you're just trying to understand how things are going to work. And so that speed and flexibility is extremely important. However, when your product starts to mature and you evolve and you start thinking about, more mass production or running multiple units per week, now you need to start thinking about fine tuning and optimizing your system for installation, leak-free, and safety for your employees. So when you get into serial production, like I was saying earlier, there's three things that come to mind. There's one, fast installation, first pass yield, which is going to be leak-free installation, and then safety for your employees. One of the areas that we see a lot of focus on is the push-to-connect assemblies. The push-to-connect assemblies provide very fast installation, repeatability in terms of installation, and also helps with routing of products. The thermoplastic hoses can be thermally formed for very tight routings and consistent routings. Another area that we see is utilizing system kits. Parker is available or has an opportunity to provide you kits for some of your subsystems, which will reduce the number of parts that you have to order, help with inventory control, and getting the parts you need where you need them on your plant floor. Another area is utilizing leak-free technology. As Nate was mentioning, O-ring seals have a very long history of providing leak-free solutions. We highly encourage that. A lot of times coming from prototyping units to serial production, a lot of MPT threads are used in the prototyping stage, which requires either use of tape or pipe dope, very inconsistent assembly. So utilizing an O-ring straight thread type of fitting or adapter is going to provide a lot more consistency and first pass yield on your plant floor. And then the next consideration is the safety and ergonomics of your employees. We highly encourage utilizing products that are lightweight, easy to assemble. A lot of the push-to-connect systems have assembly forces of 10 pounds or less. So it's something that your operators can do, day in and day out without any ergonomic strains and issues. Another area is we like to eliminate the use of hand tools. Hand tools can slip, can cut your fingers, or you can, bust your knuckles. So we highly encourage the, push-to-connect, easy to assemble, highly repeatable products. This is Jeff Berger.
Yeah, so to help keep the equipment operating efficiently, Parker offers a full portfolio of hose and fittings specifically designed for thermal management, and that's proven to absorb and redirect heat away from the critical parts. So some of our rubber solutions consist of our 7181 heater hose. It's a hose that's designed to the SAE J20R3 D2 specification. It's designed to be pushed over a hose barb and clamped We also offer crimp specifications for it with permanent crimp fittings, and then also offer J2044 connections. The 627s are thermal cooling hose. It's a peroxide cured EPDM hose that's also used on hose and barb and clamped, but then also has permanent crimp specifications available too. 807, our push lock EPDM peroxide cured hose, has just been recently released a month ago. It is a push lock style that's offered in 1/4 inch up through 1 inch, and it's designed for our push lock fittings, the 82 series. And then the product that is pretty unique to the industry is the 7395 Easy Form GS. This is a peroxide cured EPDM hose up to 1 inch, and sizes larger that are sulfur cured. And it's designed specifically to be able to bend into tight configurations to keep from kinking. This here is designed to be utilized with a customer clamp and also hose barb, or available with crimp specifications of our HYs and 43 crimps. With that, Steve?
Sure. Parker also has released a new thermoplastic solution last fall called the ECH hose for electronic cooling hose. It is lightweight, durable. We utilize a chemically resistant polyamide inner liner, which has great chemical resistance to the coolants that are being used in this market. It's a push-to-connect installation offered with the VDA connection style. We have a full complement of fittings, and we plan to continue to expand that offering as customer needs dictate. So that is available. You can reach out to us if interested. Thank you.
Parker's tube fittings division offers a wide variety of adapters in many materials, with aluminum being the most common. These adapters can incorporate the SAE J1231 hose bead, the SAE O-ring boss or BSPP end styles, as well as NPT if that is required. Our offering is ever evolving. Many customers have many different components, and their system is unique to their system. Because of this, please work with us, as we are offering many customized solutions. This holds true for manifolds as well. Different manifolds are available. Different solutions can be customized in a wide variety of sizes, designs, materials for your application. If you're interested in further information or discussion with our team, we've provided a web page with additional information and also the ability to. I will now turn it back over to Sarah for the Q&A portion of the webinar.
Great. Thank you, Nathan. And thank you all for that great presentation. It was really informative. So we've had some questions coming in, and the first one I'll offer up is, what is the cooling fluid typically used within electric vehicles and that you guys are seeing?
Sure, I'll take that. This is Jeff Berger. And so ethylene glycol in a 50% solution is kind of the most common utilized today. There's obviously variations depending upon the OEM as far as conductivity and issues like that, but that's kind of the main one.
Okay. And are there any concerns related to low temperature embrittlement of thermoplastic lines?
I'll take that one, Sarah. No, there is not. The thermoplastics that we use are highly engineered polymers. They have been used in the heavy-duty truck market and also in high-performance hydraulic systems for decades. We test them down to minus 40 degrees Fahrenheit very occasionally, and some thermoplastics that we utilize at the division, we rate to minus 70 degrees Fahrenheit. So we are utilizing high-quality polymers in our product.
Okay. That this next question then kind of, I guess, is in line with that. What kind of thermoplastic is used for the ECH hose?
Sure. There's two main polymers that are used in the ECH product. The inner material is a polyamide polymer that has phenomenal chemical resistance properties. It's plasticized for flexibility, and it also is a very robust and pretty, I don't want to say a high temperature polymer, but it can handle some pretty high temperatures in terms of the thermoplastic range. The bulk of the product is a thermoplastic elastomer. It provides the product more flexibility than other options. Thermoplastic options may be just a straight polyamide tube that would be very stiff and not really be a hose, but more like a piece of pipe. So the thermoplastic elastomer material is something that we have used in mission critical products from offshore oil and gas exploration hoses to high power or dielectric resistant utility hoses. So again, we're using highly engineered polymers for the products.
Mm-hmm. Okay. Another question related to the ECH hose. What are the sizes offered?
At this point, we launched the product with 3 sizes. They have a metric nomenclature. It is size 14, 18, and 22. And they match up with VDA fittings that are also metric nomenclature. And the fittings that we offer are size 12, 16, and 20. We have had some recent requests for 26 millimeter VDA fittings and appropriate tubing or hose, and we have some concepts in the works for that. And so we're not shy of expanding the product line, and we want to evolve with the market as our customers do.
Okay, great. So how does the battery cooling circuit transfer heat from the battery?
I'll answer that one too. So typically what we've seen is because the batteries have such a tighter range of temperature that they require, typically there's a what's called a battery thermal management system. It's an individual unit that has a heat transfer unit, a pump. It'll have generally a chiller system to chill the water when it's warm out, and also a heater unit to heat the water when it's cold out. And that's a self-contained black box unit that customers will hook up to. One supplier that I'm aware of is Thermo King, and I'm sure there's multiple others out there.
Okay, great. All right. Our next question that's come in, are low conductive coolants required in the battery cooling circuit?
Yeah, thanks, Sarah. I can take that. So typically we have not seen any requirements specific to low conductive coolants. There are some customers that are doing R&D for different coolants off of the water glycol 50/50 mix. So as of right now, it's just water glycol, but as the market evolves and the needs to cool become higher and higher, there's kind of no telling where we will end up.
I want to add to that. We did have a customer request that we do some chemical compatibility testing with the low conductivity fluid, and our product behaved the same as a standard product. So I don't think that there's any concern in terms of the material compatibility with those low conductivity fluids.
Okay, well, that's good for people to know. So our next question is, What impact does contamination have on coolant systems, and can you talk to the requirements for filtration?
So I can take part of that. This is Jeff Berger. And so whenever you get contaminants into the system, if you've got any micro channels in regards to your equipment, you have a potential to clog that up and create a hotspot, which then obviously creates either an inefficiency in the system or can actually create a failure. So filtering the system is actually highly recommended.
Stephen or Nathan, did either of you have anything you would like to add on that, or?
Yeah, I think, the critical element is probably going to be your inverters and your batteries. So I would recommend to have that discussion with those component suppliers.
Mm-hmm. Okay, great. All right. Our next question, do you see any need for insulated hoses in extreme temperature environments, and does Parker offer any self-contained insulated hoses?
Hal, you got it?
Sure. Yeah, so that does come up routinely. It hasn't been a major customer requirement per se, but we have seen that our engineering teams at Parker have been working on some novel designs in that respect. And actually, my team here in Ravenna, Ohio, are going to be making some products over the next couple of weeks for an alpha customer. So just to try to reduce condensation inside like frame units and in areas that water may collect, it seems to be one of the key areas of interest. So we think we have some solutions for that if that's a concern for you.
Okay, great. Has peroxide cured Viton seals been requested specifically for fittings?
Yeah, I'll take that one. So specifically, no, we have not. We typically use a peroxide cured EPDM for the water glycol systems. As we get into potentially some of the more unique fluids, there could be other seals that can be required, and we will go off of the media compatibility guidance from that supplier to determine what seal is required.
Okay, great. All right. Our next question from our audience, do you have any reports for the conductivity with your hose materials, such as maximums and minimums?
So on the rubber side, traditionally the rubber side is not designed to any specific conductivity requirements as far as the products that I listed earlier. They can be tested, obviously, but there's going to be a wide range. I'll kick it over to Steve in regards to thermoplastic. I don't know if you got requirements on yours.
I have not seen a customer requirement for that specific characterization, but that's something that we have the capabilities to do if needed on specific fluids. So we have fantastic test capabilities at both of our divisions. So reach out to us and we can help you walk through that.
Okay, great. Our next question, are manufacturing processes such as paint considered for these lines, and do they need to be covered before entering a paint booth or paint over?
So on rubber side, there's been customers painting rubber hose for years. So that I don't think that's really a consideration. I don't know about the thermoplastic.
We have done some studies with our materials for commonly encountered chemicals. We would need to probably look at your paint, the components of your paint just to make sure. We don't expect any issues though.
Okay, great. All right. Well, we still have time during our Q&A session, so just a reminder to the audience, if you do have questions, feel free to submit them into the question box on the side of the screen. So another one for you guys, maybe Nate, this is one that you might be able to touch on a bit, but why are straight O-ring threads preferred versus NPT?
Yeah, so straight O-ring threads provide, with the elastomeric sealing, are very reliable and utilizing the O-ring for that sealing surface, compared to NPT, which require a pipe tape or a pipe dope from a sealing perspective. When we get into production level readiness, typically your straight O-ring components can be assembled by torque and are very reliable and consistent across many different assembly personnel, compared to NPT, which have a little bit more give and take from what a good assembly procedure looks like.
Okay, great. All right, our next question, can the cooling line for a battery be a heating line?
So, from my understanding the application, the products that we both have in regards to thermoplastic and rubber can be utilized as coolant lines or also heater lines.
Okay, great. All right, our next question, Steve, this might be one for you. Is it ergonomic to install VDA fittings?
Yeah, I think I covered this in the presentation, but we'll go through it again. Yeah, the typical assembly force with the VDA fitting is about 10 pounds insertion force. That's the average for the 3 sizes that we have. So pretty low. It's a lot more ergonomic than trying to, in an odd position, trying to utilize a screwdriver or a wrench to tighten down worm clamps. So that.
Okay. Great. All right, our next question. Have any customers requested certifications to validate cooling capabilities? And if so, do you supply those?
Repeat the question.
Sure. Have any customers requested certifications to validate cooling capabilities? And if so, do you supply those?
Yeah, I mean, most of the time we work with the customers in their applications, and it's validated, with field testing from their standpoint. But as far as from my side, I've not seen that or had that request. I don't know, Steve, I don't know if you have.
Yeah, typically we will not be involved in the overall certification of a system. However, we do have the ability to make special adapters so that you can take temperature or pressure measurements throughout your system to make sure it's operating properly in the prototype stage, and help you have the equipment so that you can do your own validation.
Okay, great. All right. So our next question, and Nate, this might be one that you can touch on, Nate, since you spoke about manifolds before, but what is the typical manifold dimension, number of ports, and sizes that are going to be used?
Yeah, so we've seen manifolds have a wide variety. We've seen customers looking for some sort of a manifold solution up to 1 meter long. This is typically not a metal solution, but more of a fittings and hose type manifold solution, if you will. From a metal standpoint or a plastic standpoint, these manifolds can range anywhere from, say, 4 to 12 inches long, typically. Number of ports, there's typically a large diameter inlet and outlet. And then we've seen manifolds anywhere from 3 outlets, of a smaller size, up to, I think the largest one we've designed so far is up to 10 outlets. Some of those outlets are for distribution, and then some of those outlets are specific for sensor ports or temperature ports on them. The sizes typically on the manifolds, as Steve mentioned, would be like the size 20 VDA, the largest size VDA that there is. It can also be inch or inch and a half hose beads on the inlet and outlet. And then the distribution outlets can range anywhere from half-inch NPT, quarter-inch NPT for sensors and ports, or quarter-inch to 5/8 or 3/4 inch SAE or BSPP size range. So a wide variety of options and sizes, and we can mix match however we need to for the application.
Okay, great. All right. So our next question, this might be for you, Steve. Can the ECH hose be vacuum filled?
Yes, this seems to be one of the more questions of the day that we've starting to see as customers are going from prototypes to more serial production. Is, how are they going to fill their system as quickly as possible? And the vacuum filling seems to be the preferred method. We have tested our products. Typically what we do is we bend it to the minimum bend radius, and then we apply vacuum to it using a vacuum pump. And we ensure that there's minimal to no collapse of the hose. So the product is suitable for vacuum filling.
Okay. Great. All right. Our next question, what is a VDA fitting and how does it connect? Can you show a picture? I'm not sure if you guys had one in your presentation or if you'd be able to just kind of describe it. Or have a prop.
Where'd it go?
It was in the presentation.
Yeah, I do not have a prop. Steve may have a prop, but a VDA connection is it's a European design. It's a quick connect. I'm trying to see if I can. I'm not sure if this will pull back, but this fitting here on the right, if you can see in the presentation. Yeah, this is the VDA connection on the right here. If you need more information, the website as provided in the presentation will also have some information on it, and you can also reach out to us.
Yeah, I'll show a prop. So this is they call this the spigot. So this is the male end. There's a retaining groove up here that the fitting attaches to for retention. And then the flat stub here is where the O-ring seals on. The female fitting has typically a wire clip on it that goes into that retaining element. And it's just pushed to connect. And then the hose would be attached to the bar.
Great. Well, hopefully that helped our audience member who asked that question understand that better. All right. I think we have time for maybe just one more question here before we wrap up. So this one, maybe, Jeff, this might be one for you. What is the recommended rubber material for coolant applications?
Sure. So basically, EPDM is probably the #1 choice when it comes to an actual rubber material. And something that we're seeing is not only a EPDM, but a peroxide EPDM. And the reason being for that is fluid purity. Traditionally, sulfur cured is a normal process, but we've seen an evolution going on in probably the last 2 years of peroxide cured being kind of the main criteria for cooling.
Okay, great. All right. Okay, we've got maybe time for one more here. Is there a poka-yoke feature on dual seal connections other than pinhole to differentiate the connections?
Yeah, I think if this is in reference to the VDA, there is not a poka-yoke specifically on the VDA. What we have seen customers utilize is the VDA in conjunction with the SAE J2044, as those cannot be assembled together. and then just varying the sizes between the VDA connections in the application to make sure that your inlets are inlets and outlets are outlets.
Okay, great. All right, well, I think that is all the time that we have for today. For those questions we didn't have time to answer, we'll be sure to get back to you via email. And that concludes today's presentation. On behalf of Machine Design and Power in Motion, I'd like to thank all our speakers for their presentations today, Parker Hannifin for sponsoring today's webinar, and of course our audience for joining us. And I hope everyone has a great rest of the day.
Thank you.